आवाज आ रही है? Am I audible? Hello, am I audible? डिले है, थोड़ा डिले। Good morning, all of you. So we are starting today ELC Arduino based uh, activity, right? So it's more like a do-it-yourself, right? Activity. It's more like we can take it as this as an experience learning, right? So what we are going to do today, we are going to explore one software that's called Tinkercad, right? Right? We are going to explore this Tinkercad throughoutly, and based on this, we are going to develop few of the IoT sensors, right? Or let's say few of the IoT-based applications, right? So initially, just we need to understand what we mean by this term called intelligent system, right? So this intelligent system will comprise of two main, or let's say three main attributes. The first we call it as actuators, right? Second, we do have control, and then we do have a sensors, right? So in this three components, right, we have to make sure that there would be some kind of an analyzing between these three components, right? How we can design an intelligent system, right? So that once we have the actuator, once we have the control, and once we have the sensors. So we have to inline that okay, the actuator will do some kind of an action based on the sensory data taken from the environment, and that data, sensory data, will be processed by some control, right? So if I just go in more like a detail of individual this activity, then will followed by the presentations, right? So don't worry at all, right? First, we do have, let's say we have the control system, right? What this control system do, right? So it will basically perform some kind of an action, right, based on this. So ideally there are two types of control systems. One is we have closed, and we do have a open, right? What about did you mean by this closed system? When you are getting the feedback, right? And what do you mean by this open control system? When you have no feedback, right? For example, typical example is air conditioning. So air conditioning is more like a kind of a control system based on closed, right? And your fan is more like your control system that is open in nature, because it is not taking any feedback, right? Let's say, for example, in the AC, you can set your temperature, let's say 20 degrees centigrade, right? So after every time period, they will sense the current environment, and then their set environment. And based on this, they can tune their current temperature, right? But with the example of fan, we don't have any sensory feedback to the system. Once you switch on your fan, it's keep on running with the same RPM, right? So there is no feedback taking, right? So this is more like a kind of a control. Now coming back to the second module that is very important, where we have is called actuators. And what are these actuators? These are just more like a that are performing motion, right? Let's, for example, in a human body, we do have hand, right? So this hand is our actuator, right? We can perform various operations, something like this, right? Or let's say legs, right? So these are different examples, right? The third module that we are going to explore today more is more like a sensors. I'm just giving you a foundation that why we are studying this sensor, right? What is the need of this? Whenever you want to make a intelligent system, mechatronic system, or let's say a kind of system that need IoT based services, right? So you need these three components in line to make this one system, right? Now this system is more like a how you are perceiving the environment, right? So it's more like a sensing the environment, right? So just pardon my handwriting. It's not that good, right? Sensing the environment is like, let's say, for example, as a human being, we do have eyes, right? So that you can see the 3D world, right? So this is one of the sensor, right? If the our skin is also a kind of a sensor, right? That have a touch sensor, right? Okay. So our ear is also a kind of sensor that can hear the kind of vibrations based on the different pitch and amplitude. So these are all the sensors that are going to be used. So let's say, for example, you have camera, right? You have ultraviolet sensors, you have skin sensors, let's say, or touch sensors, right? There are multiple sensors that we are going to explore today. But what is the goal of, what is the objective of today's activity? So the objective of today's activity is, can we make an intelligent system using these key things, right? So that is why we are using one software that the link of that we have already shared to you, right, over the LMS, that how you are going to use the software. So in this software, you have a control system that we are using Arduino, right? Actually, we can use servo motors here. And sensor, we can use multiple sensors here, right? So we can start right from the scratch. So the objective is clear. We are going to explore 2 or 3 or 4 examples, right? Based on that, we'll try to give you or some problem statement, let's say around 8 to 10 statements. And based on 8 to 10 statements of problem, you have to choose, or maybe you can come up with your example or your, let's say, problem. That's fine with us. And then after this activity, we'll close the session and then we'll circulate one link to you, Zoom link, so that if you have any queries, you can just log into the Zoom account and you can have a kind of a one-to-one session, right? If you have the queries in your code, in your framework, right? So this is the more of a layout we do have. Let's say, for example, we can make a kind of an intelligent traffic system, right? We can make a kind of an pollution controller, right? We can make a smart home. We can make a kind of an industrial automation, right? We can make a kind of an service robot that will just can be used to bring water, right? It can be used to deliver the files, right? It can be used in precise agriculture. It can be used in spraying the pesticides. It can be used in order to know whether the fruit is matured or not matured. What is the level of soil content? Let's say, for example, sulfur, nitrogen, right? So it can be used in the security cameras. It can be used in order to detect the nameplate of the car, and based on that detection of the nameplate of the car, they can see, okay, whether that person is suspicious or not, right? So it can be used in multiple domains, right? So it can be used in, let's say, for example, vigilance, the face recognition, right? So multiple PIR motion systems. So multiple things can be done with these kinds of environment. So our today objective is to understand or to explore what are the various possibilities of making that intelligent system. We are not claiming that by after this activity we are competent enough to do any kind of making an intelligent system, but it's like a step first, how to start with the basic circuitry of Arduino, your sensors, and how you can make a basic coding so that you can perform all these operations at the one go or at the one plate, right? Because in order to make a real-time system, the first and primary step is to make it in the simulation, right? Once you have it in the simulation, then only you can go for the next stage, right? So that you can have it, let's say, for a real time. First, you have to run it in your simulation environment. So today we are going to explore the simulation environment so that you can reach to the first step, and then you can look ahead forward for your goals to achieve in the real time. And this activity can also be used, and I'll say, in other words, let's say, it can be very much give you a kind of a first step to go to your capstone in your third year, right? So this activity will lead you to give a kind of an exposure to these kinds of systems so that you can have a good kind of a problem selection at the time when you are reaching the third year, when you are choosing your mentor, you are choosing your capstone project. It will help you because you've already gone through all these things. Right. So without any further ado, I just have to start with the presentations, right? So I'm just stopping here to sharing this board, right? Okay, so let me share my screen and I'll directly come to the session 1. Okay. Don't worry, we're going to take your queries and everything, right? No, so don't worry at all, right? Okay, in the end, we're going to broadcast a link to you so that you can come to that link. If you have queries, we are here as a team, right? And we can have a brainstorming on one-to-one or group-to-group, right? So that is okay. Now, what we are going to do today, we're going to explore using the Arduino. So Arduino is what? It's like an open source development board, and that used for project and prototyping. So there are multiple versions of Arduino. Let me just give you an example. Let's say, for example, Arduino Uno we are going to use today. There is one called Arduino 2560. Sometimes we call it as Arduino Mega. We have Arduino Nano. And if you want to do it in the real time, where you can interface with multiple sensors, and right, there is something called ARM, right, prototype. That we have Jetson Nano board, right? If you want to deploy it using Raspberry Pi 3, Raspberry Pi 4, so there are multiple versions of these control system, right? So ideally, we are just starting with Arduino, and we can, let's say, in some other activity, we can explore the Raspberry Pi, or we can explore even the Jetson Nano board, right? So these are just the various steps that we need to follow. And apart from this Arduino is very popular, right? Particularly this Arduino Uno for the beginners to start with, at least, right? Okay. Okay, so this is the layout of this Arduino. So ideally, you can see there is one unit here. This is to give the connections, right? And this is to give you the input voltage supply, right? And this is the chip that is going to be used. And so ideally, this is the more like a controlling part, right? Okay, and this is the ports where you can give the input and the output. Microprocessor is what? It's more like they can take the inputs based on the coding, what you have done it will process that information, it will give you the output, right? So this is the role of any kind of a microprocessor. For example, let's say if you try to develop a kind of a code that will give you the XOR gate. So how you can code in this Arduino? You have to give two inputs, let's say A and B. Let's say the value of A is 0, the value of B is 1. And then you have to perform what? XOR gate. And what is that XOR gate? If I can recall, it's called A dot B plus AB dot, right? So what is this A dot B, right? A dot B plus AB dot is more like what? It's like a calculation or like a processing that is going within the circuitry, right? And based on this, it will give you the output, right? So this XOR gate, NAND gate is more like a kind of a chip. In that chip, you are giving two inputs and you are taking one output. And what that processing is doing, it's doing in the brain of the Arduino, right? So just something like this. Let's say we do have a brain, right? And the brain, the basic unit of brain is what? Is neuron. So that combination of neuron is got fired whenever you are doing some calculation. Let's say in our childhood, we do already know, right? 2 plus 2 was a very non-trivial task for us, right? But nowadays, if you ask me 2 plus 2, I can directly say 4, because we are not doing any calculation in my mind. It is being stored. It is being stored in our reflexes, right? So our neuron pattern is already got excited already by the grace of time, because we have gone through all these activities so much time that is got embedded into our neural CPG. Right? So if you say 2 plus 2, directly we inherited 2 plus 2 is 4. We don't even calculate 2 plus 2, right? It's the same thing. It's happened in this kind of a board. That is why it is led to machine learning, deep learning, and shallow learning. All these things would be a kind of an outcome of these kinds of neuron-based system learning, right? So this is ideally the part that we are going to do it today. Now, what I suggest, in the meanwhile, can you just go to your Google, or let's say Google Home, and can you type your Tinkercad, and can you just log into your student account, so that we can directly assign that, and we can just explore the basic circuitry there. In the meanwhile, just open your Tinkercad account, logged in into a student details, fill the credentials, and then so that we are on the same page when we are doing some kind of basic stuff. Okay, so I'll give you 1 minute time or 2 minute time. Take your time. We have already supplied you the link of Tinkercad over the email, right? Just logged into your Tinkercad account, sign in as a student, and just let me know over the comments that whether you have reached there, so that we can start. In the meanwhile, I'll just maybe directly we can start from here itself. Yeah, and even ask your peer groups to join multiple to join this session, right? Because it is automatically being taken care by the attendance, because who is joining it will be already populating some Excel sheet out of it, right? So please encourage your peers, or maybe your colleagues to join this session, right? And please just post into your WhatsApp group to your fellow mates so that they can join, right? And they can even join from their phone, because it's just a matter of getting the live feed, right? And you can just see what we are doing it here, and based on this you can have the ideas, and then you can implement your ideas there, right? So I'm just giving you 1 minute time. In that time, just try to log in into a Tinkercad account, and just let me know over the comments whether you have joined or not. Okay, so we are just waiting for 1 more minute. Let the other student join, and in the meanwhile, who have already joined, just follow the steps that has we have already mailed it to you, right? Just log into a Tinkercad account, and then we can start with the framework, right? Because we are just starting with from very scratch, right? We are assuming that we are just introducing a new, let's say, kind of framework to you. So we are just starting right from the framework design, right? Okay, yeah. Okay, so let's start from here, right? Okay. So this is the framework you can see, right? Let me just use this. So this is the framework, right? So ideally, this you can see, right? So we do have multiple options here, right? We can even add everything, right? We can add the LEDs, we can add the registers, we can add the buttons, even we can add multiple things here, right? So what are the basic things here? So the basic thing is, let me just go there. So ideally, this you can see this layout, right? So you can just do this. So ideally, you can just perform the drag and drop, right? So you can see this Arduino board. You just drag it here, right? In the same way, you can drag multiple options. Let's say you can drag the LED, you can drag the registers, and multiple options you do have. So ideally, even you can make a kind of a breadboard, right? And you just drag that breadboard here, and based on this, you can perform various operations, just something like this, right? So how you can connect a breadboard here? So ideally, you can see you can connect this positive, right? You can see this positive. So this positive is being connected to the power. So what is power? Here is, let's say, 5 volt, right? And this is connected to the ground. So this is a negative, and this is the ground, right? So a LED has two parts. One is called cathode. The second is called anode, right? So this cathode is always connected to the negative, cathode is connected to negative, anode is connected to the positive. Means anode should be connected to this resistor, and this resistor is connected to this positive. That is why you can have this LED blinking on light. You can make set it as a high, right? So this is just a pretty example of how you can use a breadboard in the even in the software also, and even you can do it in the real time. You just need to purchase a breadboard. You need one LED, two wires, one resistor, and you connect your LED cathode to negative and your LED anode to positive 5-volt. And based on this, if you want to control the LED blinking, then you have to connect it to the Arduino board. Otherwise, if you just want to keep on running high that LED, there is no need of Arduino at this moment of time. It means Arduino is acting like a kind of a brain to our intelligent system, right? So whenever you want to control your hardware, then you need an Arduino system so that you can perform some kind of switching between the logics, whether it's a NAND gate, whether it's a NOR gate, or whether it's an AND or XOR and multiple gates, right? So whenever you are using the Arduino, it means you are developing or you are making a kind of an action-based performance, right? Based on some input, your action is different. Based on a, let's say, input Y, your action is A, and based on input Z, your actions are B, right? So based on this, it is going to be there. So let us discuss one. It's called blinking of LED circuit. So let me just directly go to the Tinkercad. Okay, so I'm just sharing new. Okay, is that? Yeah. Okay. So are you able to see the screen, right? Okay, so let's understand the layout of this, right? Okay, so you can see this is the blinking LED structure, right? So you can see that this section we call it as code. It means you can directly code exactly what you want to do it here, right? For example, this code contains what? This contains one function we call it as setup. It means whenever you are running this code, right, it will start from here itself. It means it is giving a kind of what are the initials to the system, right? So this setup is more like, let me write it here, more like a initial parameters that need to be specified, right? Ideally, in this setup is more like you are giving the initial parameters that, okay, I am going to use one LED, right? And initially I'm setting that LED as a name called LED underscore build, right? And then you run this void loop. This void loop is what is more like a that you need to rerun every time. Exactly, let's say if you want to run any code, right, X number of times, then you can just perform it into the void loop, right? Now, how you can perform this, how you can add this Arduino. So you just directly go to here. Either you can search this called Arduino, right? And you can see it here. And then you just directly drag it here only, right? Is it okay? Right? Now, let's say if you want to make a register connected to the LED, so you can drag something like this. You can drag it here, and you can drag one register here. Now, how you connect this register to this LED? You can see in this LED, you can see one point is called cathode. The second point is called anode, right? So you just connect this anode, so this cathode to this section, right? And you connect this thing to the ground. You can see the channels. Okay, let us discuss this also. Let me just zoom it. Let us discuss this, right? Okay, so you can see this is the Arduino board, right? So these are the channels. You can see this G and D. G and D is more like these are the grounds. This 5-volt and 3.5 volts are the input voltage. It means you can give power to your LED from here. Either you can give 5-volt or you can give 3.3 volts, right? And based on this, you can see multiple analog inputs are there, right? And there are, we call it as digital pins. So what do you mean by these digital pin? Means you can connect one end of the LED to the digital pin, right? And the second end of the LED to the ground. And you code accordingly that you have to mention that this LED is going to be connected to this 7. So how you can code it here? It means you have to write in the code that this LED is connected to pin number 7, and this section of the LED is connected to the ground. Are you getting my point? It means if you want to connect any system, right, to the Arduino, it means you need to specify two things. First, where individual component you are connecting to. Second, from where you are giving the input. Either you are selecting 5 volt or you are selecting 3.3 volt. Based on these parameters, we need to understand that how, then based on this, how you can perform the actions, right? Okay, so let us do that also. Let me see. Okay. Okay, right. So let's say let me, I have connected what? This is the one red LED. I can make also any color, right? We can make it yellow, orange, blue, red, or white, depending upon the application, right? What I have done, you can see the cathode, right? Let me just zoom in for you. You can see the cathode is connected to ground, right? The other part, this node is connected to this resistor, right? And now this resistor is connected to where is called pin number 13. So this red LED is connected to, positive is connected to the 13, and the negative terminal is connected to the ground, right? In the same way, you can see one more LED here, right? So second LED, you can see the cathode is connected to resistor and the anode is connected to this positive, right? You can see it here. So this is positive line. So this anode is connected to positive, right? And this cathode is connected to the negative. Negative is more like a ground, right? Okay, so you can see this negative is connected to ground, and this positive is connected to which port number? It is connected to 13. So what does it mean? The summary of this layout is there are two LEDs. One is red, the other is green. Both cathode is connected to where? The cathode is connected to 13, but the anode is connected to positive. And this positive is what? Is your point number line this. So ideally this anode, both anode is connected to 13, but the cathode, both the cathode is connected to the ground. So what does it mean? It means one end of the LED should connect to the negative, the another end should connect to the positive. Negative would be ground, positive would be the port where you are listening the values, where you want to listen it, or where from where the Arduino will take as an input, right? So if you want to code this layout into this section, so you just click on this, and now let me explain this thing, right? So you can see it here. There is one called pin mode, right? And then you are just doing this digital write. So what does it mean? Digital write means you are writing over this LED with high. And what do you mean by high here? High is more like it's glow. It will be glowing, right? It means it is right. So this is, it's more like it is glowing, right? It means it is high. It is on, or let's say we can make it as on, right? What do you mean by this? 3D is low. It means it is off in nature. Right now, what is this term called delay? This is more like for 100 milliseconds, we just want that LED to be on, and after 100 milliseconds, we want that LED to be low. That is why we are doing just kind of a blinking of LEDs. Right? Okay. So this is the complete architecture we need to understand. And there are multiple ways of doing it. This is the text-based coding. You can either select block-based. If you just click on this text and go to the blocks, And if you want to continue, you can see the blocks here, right? So based on this also you can perform, okay, this block, if you, according to the blocks you can code. There is no need of writing the code, right? But I will suggest you to select the text only. The reason is because it is much more viable, because most of the time we are doing the coding in the text only. For just the sake of this environment, if we change our mode of coding, it will not improvise our kind of an the writing speed, the coding speed, even the understanding the layout of the code, right? So I will suggest you to follow the text based coding rather than the block based, because not every time we are going to use block in other architecture, for example the Python, or let's say Visual C++, or let's say Visual C Sharp, or let's say Java, Eclipse, whatever platform uh, IDE environment you are using. It's better to go with the text based coding rather than the block based, right? Now once you've done the coding, right, then what you have to do, you just have to run this thing so that you can see your output, right? You can just click on this code so that the toggle code editor will go away, something like this, and then you can start simulating it. Right now you can see what is happening. Are you able to see the changes in the LED? And let me just increase or decrease this LED intensity. So if you, I can just stop simulating. You can see it is 100 ohm resistor, right? So I just want to make it 10, right? And in the same way, I even make it 10. The reason being because V equals to IR, right? Voltage is equivalent to what? I into resistor. So if you want to decrease a resistor, the corresponding current will increase, right? So ideally V is directly proportional to I, right? So that is why if you want to make the intensity higher, you can tune the value of this resistor. So you can even change the resistor based on the ohms, mega ohms, micro ohms, or even giga ohms, right? So let me just run it for you one more time. So ideally you can see this, right? So this is the smart start simulation, and then you can see, now you can see it is glowing in much higher intensity. Okay. Yeah. So ideally, you can, if there is some error, it will show it here itself. The error. Let's say, for example, okay, let's make it anything, right? Something like this, right? And if I just start simulating, it will show error in the in your that portal only, right? That okay, this is not this is pin mode is not defined. Okay, right? So in this, you can just make sure you are writing in a good context, and then you can see the changes. Okay. Sometimes what happens, if you let's say for example, if you make the resistance too low, right? So sometimes it will give you the warning that okay, the resistance is very low. It may harm your design whenever you are going to real time doing that performance. Let's say for example, in the simulation it is working fine, but with the warnings, right? But you, once you directly deploy this code, this thing into the real time Arduino board, it may burn out your Arduino. Reason being because here there is no facility of warning, because ideally the current is flowing in the real time, right? So that is why you have to make sure that there would also not be any warning if you're running into the simulation, right? So please changes or accordingly the resistance value also. Ideally, we are not here to discuss the electronic section also. We are just going to discuss how we can implement this thing in order to make kind of an intelligent system or IoT based environment or IoT based systems, right? So this is the first layout that we can just, I just have to give it to you so that you can have a basic understanding that how you can at least attach your basic LEDs to the Arduino board, right? Now let's come to the second. Let's take one more example. Let's take the moisture sensors. Okay, so you can see it here from, so what I'm we are using here, we are using one sensor called soil sensor, right? It's more like it will select the moisture from the soil, and based on the content of the moisture present in the soil, it will give you the value based on this. We are taking that value into our Arduino board, and depending upon what value we are going to actuate, let's say if the moisture level of that soil is 40, and on that night there was a rain, right? So the moisture level of that soil will have to be increased from 40 to, let's say, 200. Now we have to make the action that, okay, now we don't want to make our pump on, right? We don't want water to our fields, right? So we can make an intelligent system there based on the content of the moisture present in the soil for yesterday. Based on this, we can dispense out the water volume. Let's say yesterday night there was no rain, right? And the moisture level of that soil was, let's say, 40. Now today there was some, let's say, some rain, right? Now the moisture level increased from 40 to 90, or let's say 120. Now at that moment of time we don't want that amount of water to be dispensed out. So we can make a kind of an intelligent system here. We can place multiple sensors over the field. We can get the data from some kind of a wireless sensor network unit. Once we get the data from WSN, means wireless sensor network, then based on this we can act on it. And who is doing the acting, who is doing the actual let's say action management or action taking unit? It's our Arduino board. So it's like a replica. What we are showing it here is based on the moisture level, this LED will give you the markings. Let's say if the moisture level is low, you can see this LED will be glow. If the moisture level is little bit high, then the second, then the third, and then the fourth, and finally the fifth. Right? How you get to this? So ideally, what you'll do, you just add this Arduino from here itself, something like this. You just drag drop here. Now you want this breadboard. So there are two ways of doing it. There is one called mini, and the other is called micro. You just type this thing. Even you can select small, normal breadboard, and even the mini. So what you will do, you just drag on this mini breadboard here. Okay. Now what you want to connect this soil sensor. Just go to here, the search section, type soil sensor, soil moisture sensor. Once you click on this, you will see the sensor, right? And you just drag drop from here itself. Now you can see there are 3 units connected to this soil sensor. Let me just zoom in for you. First is this VCC. What this VCC means, it's already showing the help unit is power. It means you need to connect this unit to the 5 volt. So just attach this wire, something like this, right? And you just connect to the 5 volt. In the same way, you have this ground. Ideally, you just connect this wire to the ground section, right? The third section we do have is a signal, right? Signal means from where you are registering the data that you have taken from the sensors, right? So based on these 3 inputs, we have VCC, ground, and signal. This signal data is going to be dispensed out from the soil sensor and going to be input to your Arduino board, right? So this is a layout that we need to understand. Now, based on the signal where you are giving input to the Arduino board, then you can perform the coding, right? So let me zoom out for you, and then we'll try to understand how you can work on this, right? Okay, so we can just go to this code here. Now you can see there are how many pins are being connected. So ideally, you can see it here. There are 5 LEDs. One LED is connected to the 8 pin. You can see one LED is connected to the 8 pin. You can see this one, the blue one. Now this one is connected to the 9th LED, so 9th port, sorry. Let me just zoom it for you. You can see the 10th LED is connecting here. You can see the 11th LED is this one. So ideally, all the LEDs is connected. What does it mean? It means based on the moisture level content, LED will be activated. If the moisture content is very low, the first LED will be high, right? If the moisture level is somewhat higher than the previous one, the second LED will be high. If the third, let's say the moisture is, let's say, above some range, the third LED will be high. Based on these moisture level content, we can code our system so that once the LED is very high, let's say this, we'll not going to dispense out any water from our, let's say, water tank, or let's say where we are storing the water, something like this. So all the LEDs are connected in series here. You can see now this is being connected, but where are the code where you are giving the ground? You can give the ground based on a single register, right? So you are just connecting one single register, and based on this, you are doing the, this is we call it as sorting. So you sort the wire. Let's say you can see this is sorted here. This is again sorted. This is again sorted in this line. So ideally, you can connect it in series and you sort this wire. So ideally, everyone will get the negative ground. So you don't need to connect it individually. You have sorted this complete grid. Sort the matlab, it will be SHORT, means you sorted the wire, means you have sorted one wire and every line is negative only. Either you connect to X or Y or Z location. The complete horizontal line is got sorted, right? So this is going to be happening here. Now, how you can connect to this oil sensor? Let me just do it for you. You can see it here. I've already conveyed to this already that this VCC is the power. So you can see, and this is the ground, right? And you can see this is the A0 and A1. So ideally, you can see this is the input to your system by A1, and this is the output, from where you are registering the values. For a sensor, there would be two things. One, from where it is getting the input as a voltage, and there would be one connection from where it is getting the output. And that output should be dispensed into your Arduino. Right? So here are three components. First is we are using soil sensor as an actuating unit, or as a sensing unit. And based on the sensor value, we are getting that data into our controller or microcontroller. Based on the data, we are making a code using if condition, else condition, using do condition, do while, looping, right? Based on some kind of a conditional statement, and then we are giving actuation. And what are actuation here? We are not connecting any robot here, but what is the actuation unit here? The actuation unit is the glowing of LED, and the glowing of LED is depending upon the moisture content of the soil. Right? Okay. So you can, now we can go with the void loops. Ideally, we already said this void setup. So ideally, why we are connected to this A0 is because we want the sensor to be high or low. Right? Now, based on this, I've already conveyed this setup is going to be initializing all your data. So it's like initialization, like we do function declaration, right? In the same way, we are just initializing how many LEDs we are using, how many analog inputs we are using, and based on this, we are doing the different initialization there. Void loop is more like here you can perform the operations, here you can perform the activations, right? So ideally, what we are doing, we are taking the analog read A1 into the moisture. So what you can see, analog read A1. What do you mean by analog read A1? A1 you can see is your pin mode, where you are taking this as an input. So you can take the moisture level values, and where it goes into the moisture variable, right? So here is a variable called moisture. It is taking the data from the soil sensors, right? And based on this, you are serial printing also that moisture. So even you can print it here itself in the console. Once we run it, I'll show you what is the content level we are getting. And based on this, if the value is moisture value is less than 200, you must write only the 12 is high. And what is this 12? Where is the 12 here? You can see 12 is this one. What does it mean? It means if the moisture value is less than 200, only the LED that is already connected to pin number 12 is glow or is high. Rest LEDs will be off or low, right? Else, then we come to else condition. If the moisture is less than 400, what does it mean? It means it is greater than 200 but less than 400. It means the moisture level is in some range, and that range is greater than 200 and less than 400. It means only digital 11, right, means the LED that is connected to 11 port is the high, rest all will be low. What does it mean? It means your second LED will be high, the first, third, fourth, fifth will be off. In the same way, if the moisture is less than 600 and greater than 400, there is one more condition, right? Then which LED will be high? The LED that is connected to the 10. If the moisture level is greater than 400 and less than 800, then the LED will be high, that is already connected to the port number 9. Right? And at the last, if the moisture level is greater than or equals to 100, because you can see there is no equal to sign, right? Right? So based on this, if the moisture level is greater than 800, then the digital write 8 means LED that is connected to the 8 port is going to be high, rest all will be off. Now you obviously need to explore the function called digital write, delay, and serial.println. Let me just give you a brief idea about these three functions. Digital write is more like you are assigning a value and you're writing that value on that port. It's something like that. Let's say you're writing over notepad, right? Let's say you're writing your name. What you are doing it, you are ideally you are writing into some file, right? In the same way, when you want to assign some value to the port, then what is the modus of operandi for that? The modus of operandi of that is you have to do the digital write, right? And that digital write will be in the form of some port number and what value you want to make sure. So let us just explore this thing. Digital write bracket 11 comma high. What does it mean? It means we do have a function called digital write, and in digital write we do have a port called 11, and we want to set that port high. High means that port set high means it will have a 5 volt of voltage. Any LED connected to that port will be glown on because you are supplying 5 volt to that. So ideally what you are doing here, you are giving a kind of an control or a kind of an action based management here, right? So ideally it's more like yes, it's more like a setting port to 5 volt, or let's say too high, sorry, at where, which port? At port number 11, at port number 11, right? But imagine if you don't have this Arduino board, what is going to happen? Can you control the glowing of LEDs with corresponding to the moisture content? No, because you will be having only two options. Either you can make your LED on or you can make it LED off, irrespective of what? Irrespective of the data that is there in the moisture control. So can you tell me, I have already explored this, that is it a kind of a closed loop control or open loop? This is more like a closed loop. Reason being, because every time your motion sensor is sensing from the environment, depending upon the value, the LED will be changing. And based on this, you can now, what is the second we have to do is we have to run that code. So you just click on this code, right? And you just start simulating, and let me just zoom out for you so that you have better understanding here. Yeah. So let me just run this code. Right. So now you can see one change here. You can now, this is the, you can select in the simulation, because this is not in the real time, right? In the real time, you have to dip this sensor into the soil, and based on the water content, it will give you the output. But here is more like a simulation based understanding, right? So now this initial is you're having very low level of moisture. When you are changing from here to here, you can see the change of the LED. Are you able to see it, right? What does it mean? It means when the content is low, the first LED will be glow on. When the content moisture is high, the second. When the content is much higher, than third and fourth and fifth and so on and so forth. Even we can also make some changes over the resistor so that you can see it with more high intensity of the LED. Okay, so you can see, right? Based on this, you can even make a kind of from this only you can make a kind of an automated irrigation system based understanding, right? The reason is depending upon the water content, you are dispensing that amount of water only. So there would be preservation or conservation of water. There would be conservation of electricity because you have to dispense out the water using some kind of a water pump, right? Or tube well. So you can save the electricity, the water, right? So all these things can be encountered. You can think of making an IoT based system using soil sensors, temperature sensor, right? Humidity sensor, and all these sensors, right? So this is the basic understanding. Maybe I will share these examples over the LMS also with code and everything so that you can have a better understanding, right? Okay. Okay, so let me just go to the, let's say, the third example. Just allow me a minute. Okay. In this example, it's again one more sensor that we are going to understand is we call it as ultrasonic sensor. What do you mean by this ultrasonic sensor? Ultrasonic sensor is more like, let's say, if there is an object, right? If there is an object, this, I'm not sure how to see this or not. Yeah. So if there's an object, right, and there is some sensors. So based on the distance between the sensor and the object, if you want to actuate something, so how you can make that happen? It means you can implement a ultrasonic sensor there. It means based on the distance between the sensor and some object where you want to deploy it, you can perform these kinds of operations. For example, it can be used in autonomous driving cars. It can be used for service robots. Let's say you are looking for a robot that will give a kind of a mobbing to the floor. So you have to apply the ultraviolet ultrasonic sensor because they have to make sure that it is reaching to all the points of the floor, right? It should not hit the wall, right? There would be some threshold between the wall and the robot, right? So you can place this ultrasonic sensor, right? It's again, you can use this using, we can just do this ultrasonic, and based on this, you click on this and you can just drag and drop it in the same way, right? So it's again, you can have the three inputs here, right? First is the ground. You just connect this ground to the ground channel of the Arduino. This is 5 volt. You just give this 5 volt here from this section. You can see 5 volt, right? This is a signal actually. This signal is, now you can register the distance between the data and the sensor, and you can dispense the value in the port number 7. So ideally, what this layout will give you, based on some distance between sensor and the object, if it is coming too close towards the sensor, the red LED will be glowed on, or let's say will be high. If the object is going far away from the let's say sensor, based on some threshold, the green LED will be glowed on. Just think of a kind of a example. Let's say, for example, you place a sensor on the back of your car, right? And you want to do the car parking, right? And you can't see back, you don't have, let's say, rear let's say mirror, right? So based on this sensor, nowadays even the cars have only this sensor, right? You can see a small circular ring over the back of the car, right? These are the sensors that we are using. So based on the kind of threshold between the wall and the car, you can set, and it will give you alarm whenever it is crossing that threshold. So whenever I'm coming towards it means there is very narrow distance between the car and the wall. It means it will show the red LEDs. When it is coming away after the threshold, it will give you the green LEDs will be on, right? So let me just go to the direct the code, and then we'll try to understand, right? So there is one function called read ultrasonic distance. What do you mean by this? We have to define a function that will take the values from the environment, right? Write that value on the port number 7, and our Arduino will read that value from port number 7. Based on the data we have gathered from port number 7, we will trigger red LED or green LED. And this read ultrasonic distance is more like a user defined function. You can make your own function. I presume you already gone through your C language, right? in your first semester. So in this, there were two ways, right? You can make your own functions. For the function, you need function definition, function declaration, and function calling. Right now we are dealing with function declaration, sorry, function definition, and then we can call that function whenever we need to take the data, whenever we need to access the data, right? So in this, you can make your own function called read ultrasonic distance. Here you have two parameters. That means you will be having two calling, or let's say kind of in parameters. What kind of function parameters do we have? Either we can have call by value or we can have call by reference, right? Here we are using call by value. Reason being, we are not using any pointer concept here. That is why all the parameters that what we are calling it here is call by value by default. Right? Okay. So in this, we are having two parameters. One is called trigger pin. The second is called echo pin. It means one is going to trigger the sensor. Second will going to register that output of the triggering. Right? It's more like one parameter is more like a triggering that event. Second is getting the response of that trigger. Right? So in this, what we are doing, we are just digital writing the trigger pin low, and in this we are giving the trigger pin as an output, right? So based on this, we are performing this kind of a user defined function, and we can return what we have to return. We can return two outputs. One is the echo pin, the second is the high, whether you want to make it high or low. This is more like a user defined data function. Now in the set, what you are going to do, you are generating 4 LEDs. 2 LED we are making as red, 2 LEDs we are making as green. The red is connected to port number 5 and 4. Right? So let me just go to here for you so that you can see. This LED is connected to 5. Yes or no? Right? This is connected to 4. It means whenever the ultrasonic data, the sensor is data is getting too close to the threshold, or it is crossing the threshold, it means you need to set port number 5 and 4 to be high. Whenever it is greater than the threshold, it means the object is away from the sensor. What does it mean? You need to make the port number 3 and 2 to be high, means your green should be bulged out. Are you getting my point? This is more like a giving an initialization. I'm writing one more time here. Everything that we need to initialize here, we need to perform it here. Initialization, right, of the parameters, or let's say better way, very easy. Yeah, and even for the resetting the pins, right? So in this, now we'll come to this while loop. It means it keep on running. It's more like a listening. Every time it is keep on listening, right? Something like this, let's say while one, right? While one is what, or while true is what? It's keep on listening till your while condition make it false. Is this false? Are you getting my point? So in this, what we are doing, ideally this read ultrasonic sensor is taking data in terms of inch. The distance is inch as in dimension. So we already know 1 inch is equivalent to 2.5 centimeter, right? So we can convert the corresponding inch into the centimeters. You can see it here. So this inch is equal to centimeter by 2.54, right? If the data, the inch is greater than 40, what does it mean? We have to make sure 3,2 would be high. And what is 3,2 is? Green. What does it mean? If it means whenever the object is away from the sensor and the value is greater than 40, it means you can give the green LED. But if the object is coming towards the sensor and the value is less than 40, it means there is some problem is going to be encountered. It means we are representing that problem by some representation called red LEDs. So you can see it here. From this only 5 inch, if condition, from this if condition, you can represent one logic. In the else condition, you can represent this other logic. It means it is moving away. So in if and else condition, you can perform this logic building. And finally, you can print this thing here. Sorry, right? Let me just run it, and then we'll see also what the output we are getting. Okay. So you can see once I click on this, you can see this number. Are you able to see the number, right? So based on this data, if I'm moving away, this take this circular disc as the object. If I'm moving away, you can see red LED is already bulging out, right? Is already on. Now, if I'm moving towards the sensor and if I'm crossing that 40 limit, you can see the red LED is going to be hit. Let me just change this value. Let me just go here and let me just make that as let's say 60. So accordingly, it will behave, right? So let's start simulating it. And if you want to see the code that is being popped up, you can see it here, right? Just a moment. Okay. Now we have increased to 40. Sorry, 60. Now after 60, it is giving the range. Ideally, you can change the threshold only. Even you can see which data is going to be dispensed out. I just want, okay. Yeah, you can see. You can see what is the current value here you are getting, right? So it's right now it is sensing 58 inches, and that is equivalent to 148 centimeter. 2.54, 1 inch equals to 2.54 centimeter, right? So based on this, you can take this as a kind of an understanding of more like a let's say you just place a sensor over your door or over your window. In the night time, you activated it. If in the night time, if somebody is approaching towards the window or someone's trying to break into your home, so if someone is approaching very close to your window or let's say to the door, the alarm can be blown on, right? So just take this as an kind of an uh, application or as an example in that scenario. It can be used for the rodent control also. Very, very good. What do you mean by this? If let's say if the rodent is approaching to that side, right, you can activate your kind of an uh, more like that you can catch it, something like that, right? And then accordingly it will behave, right? So this is just one sensor. It can be applicable in multiple domains. It's never less that okay, only one sensor can be used in one application. No, you can use multiple sensors. But the problem is there that we call as sensor fusion. How you can do multiple sensors, how you can dispense into one control unit. So there is a term called sensor fusion. Means based on the different sensor, you can make a pool of sensor and you can fuse all the sensor data on the whiteboard. And based on the whiteboard data, you can render or you can dispense out accordingly what you want to achieve, right? So there are multiple examples I do have with me. We can explore a number of examples here, right? So depending upon let's say what kind of application you want, right? Now let us go for one more application, right? It's more like, let's say if you want to make some activator in this unit, you can see all the three modules. This is the control part. Yeah, you can even use for the old people monitoring that example, right? Now we'll just switching to one more example. It's more like a, let's say here you can see one control unit, one sensor unit, and this is the activation. Even you can see the activation. So what we are doing, if someone is coming close towards, it is giving you red LED is on, and based on this, it will give some activation. Let's say if I coming towards the sensor, the shaft of the servo motor is moving anti-clockwise. If I'm moving away from the sensor, the shaft of the servo motor is moving clockwise. It just give you a representation that how you can just think of it, the hinge of a door. If somebody is coming towards your home and your door is open already, you can make that door to be closed, right? In the same way, if someone is coming towards you and you can see it over the screen that okay, my friend is coming, automatically you can open the door can be opened in the vice versa direction, right? So ideally, what I'm doing it here, what we are explaining it here, you can make or visualize multiple operation or multiple application based on these single entities. When you club together, perform sensor fusion, then you can make a kind of an IoT based framework. So the overall objective of this ELC is we're going to explore few of the examples with you. We're going to give you pool of ideas. Then you come up with your own idea that, okay, sir, we want to do this as an individual. Follow the steps that is being mentioned over the LMS, right? Follow it. Make a PDF document. The draft of the document is already shared it to you, right? And just deploy your results and everything, right? So it's more like an experiential learning, right? It's not like that we just have to make sure each and everything here itself. We can give you the ideas, we can give you the initiation, we can give you some push, right? But actual walking has to be done by you only, right? We can assist you, we can guide you, right? So that you can't skid. Are you getting my point? So it's more like you have to explore from yourself. I'll share all these. Yeah, I'll share all these examples to you over the LMS. We'll share the complete code and everything, right? No problem with us. The what we want from your side is make use of that already existing work and put it into your own application, right? Take this that example as a reference, not the final melting point, right? Yeah, so we can share all these things. So let me just run it for you, and then we will go for the final conclusion of this activity. And then, so let's start simulating it. You can see, right? So if, let's say, if I'm moving away and if I'm moving towards, right? Depending upon, it can sync this LED, it is moving in anti-clockwise. If I'm moving away, the green LED is on and it is moving clockwise. Let me do one more time for you. You can see. Depending upon what is the distance between you and the sensor, if it is very close, it will go in one direction. If it is far away, it will go in another direction. And then you can attach the hinge of your door or window to this shaft and make it dispense to your LCD phone, or sorry, the mobile phone or some tablet, so that you can see who is coming, and based on this you can see that okay, the door is already open. Or you can make one more, you can just input one more fingerprint scanner over your door, and you can see the face, the fingerprint matching, and door will already open up. So are you getting my point? So based on these examples, it is always good to understand that not from the only single sensor you can achieve all the security levels of a smart home, but with multiple sensor you can validate. Sensor 1 will validate sensor 2 data will validate on sensor 3, and so on and so forth, and finally you can dispense out the output, right? And in this you can also record the movement of the old people. Let's say if the old people is, let's say, fall down by mistake, let's say for example, you can have some alert, you can have some kind of a notification over your phone based on the sensor data that they are collecting. So it can be used in multiple and viable nature, right? Okay. Okay, so I'm just right now stop sharing it, the screen. So now what we make out of it, what we have covered till now, it's in more or less like a 110 minutes, is we just need to explore multiple outputs. It's not like only one ultrasonic sensor or one UV sensor, or let's say touch sensor we are using. We can use n number of sensor here, right? Now what we want from you, what we are expecting out as an deliverable for this activity is go through the content shared over the LMS, right? We will share all the examples, around 8 to 10 examples we do have. We will share it with you with code and everything. Try to go through the draft of report writing. In that you have to make your project name, what sensor you need, right? And to be just follow the rules is it has to be individual basis, right? Then based on that, you need to compile each and everything, right, into a PDF, shared it over the LMS with your name underscore with your roll number .pdf file, right? Last date we have already given is 31st of March. Let me just go through the design or format that you have to follow. Let me share my screen. So this is a layout that you have to follow, right? It's already been shared over the LMS. You have to make sure what kind of problem statement you are going for, what is the need of that problem, that is very important. Why you are going to make a smart home, what is the need, what will be what kind of sensor you are going to place. Is there any already pre-existing solutions are there? If yes, okay, how your solution will help or will try to counter the demerits of that solution, right? Then you can compare the need with the existing solution. What is the need of it? If already solution is there, why you are developing a new one? Why we are wasting our time, right? We just want to make that thing to be much more fruitful, much viable in terms of getting the real time solutions from these activities. If out of 1500 students, if 10% got some solution, right? So it means 1500 people out of 10 is 150, right? So 150 solutions we can get it from this activity. If we just suppress down to 5%, so at least 75 solutions we can have it. And what is the outcome? 5% people got the right answers, right? It means still we have 75 solutions. Are you getting my point? So these steps we need to follow. Now, what do we mean by this? Is sketching the design process. So let me just share the slide. Oh, sorry, the link. So from here, you can see, right? You can see this thing, right? Even you can see the schematic view. You can see this complete circuit can be automatically schemated here. You can see automatically it got into place. You don't need to create of your own. You can just take this and download this as a PDF. It got downloaded. Let me just reshare one more time. You can see it has been already dispensed out. You can also add this thing into your report. That okay, my solution is this. This is the code of solution. This is the code of my project. This is the layout, and this is the schematic layout of this. And you don't have to create of your own. It will be created automatically by the software, right? Okay, so this thing you have to follow while going through this activity template. Now, what we are going to do, we are going to give you a link over the LMS at around 11 a.m. If anyone have any queries, just present there. We can solve your queries, right? You can select your own problem statement, right? I can give you n number of problems here. Let's say, for example, right from starting, we can give uh, precise agriculture systems, right? Right? Traffic light management, home automation, industrial automation, right? Security cameras, right? Social robots, autonomous vehicle system, right? Anti-theft systems, right? Let's say monitoring the old people, right? Uh, you can have multiple things, right? Small child sleep monitoring. If your child is sleeping, you can monitor it, right? If he or she wakes up, you can give some kind of an alarm to your phone or something, right? You can go for the rodent control, right? You can use for let's say precise agriculture. You can use for the spraying. You can get the soil content, whether your soil is having nitrogen, sulfur, the water content, how much urea you have to dispense out. Because if the nitrogen content is very high to your soil, there is no need for giving you the higher urea, right? Higher level of urea, because it will going to burn your crops, or even going to waste your money of being giving more and more urea to the, right? And even you can, in this pandemic time, even you can go for people counting, right? If the number of people is much higher at small area, you can give some alarm to the security unit or to the higher authority. So it can be used for multiple options, right? It can be used for multiple domains, right? It can be used for some kind of an navigation robot, right? It can be used for service robot. It can be used for the in the hospitality, right? If someone wants to deliver a medicine from location A to B in the hospital, it can be used by robot, and that robot will have some wheels. They have ultrasonic sensor so that they cannot hit the wall, they can hit the people, and they can deliver multiple few things, right? The basic necessary things, right? So this is the layout that you can select any topic, right? Maybe from these list, I have listed around 10 to 12 topics. You can go through your own, right? It will be on the individual basis by 31st of March. Don't copy it from the internet source, right? We do have Turnitin, we do have a plague, anti-plague softwares and everything, right? So don't copy it. Just follow the basics, what we have got gathered today, right? Try to achieve a basic let's say layout. And we are not looking for a kind of a hybrid or complex system, since you are second semester student, right? So no problem. So just go with that. We will be available around 11 a.m. over the Zoom. right? And if you have any queries, we can have one-to-one interaction. And please write your comments, your roll number against your name, right, in the comment section also. Okay. Right? So please write in comments your roll number against your name. Please don't copy it. Please follow the procedures or steps that is being shared over the LMS, right? With all the schematic representation. Even we just need to know the code also. Just do it in one doc file, convert it into a PDF, and send it over the LMS, right? Okay. So anything you want to share? Okay, so we are not officially closing the ELC activity as of now. We are just switching from one framework to another. We will be sharing the Zoom link over the LMS for the discussion or for the Q&A session, right? And we are here till 5, so no worries, no problem. You can just contact us. We can have a one-to-one session over the Zoom. So there is no problem until unless you have the questions. We as a team don't have any problem to let's say serve that problem or to cater the problems, right? Okay, so I really thank you all for joining. I really thank you, my team, for giving me this opportunity, for getting this thing, everything happened, right? So I wish you all the best, and I'll be sharing the link over the LMS not more than in latest by 11:05 a.m. Right? Yeah. Okay. Okay. Thank you so much. And just logged into your Zoom, whatever queries you have, because you can ask the questions over the comments. So what I think, whoever have some issues, just logged into the Zoom. We can make some rooms in the breakout rooms in the Zoom, and then we can have one-to-one discussion based on the same. Right? Okay. Thank you so much. Thank you so much for your time. Happy learning. Thank you.